Hello and welcome to Cloud on Board, Core Infrastructure Fundamentals with Google Cloud. Thank you for tuning in. This is your first step on learning journey towards becoming an expert Google Cloud certified professional. If you have any questions throughout today's event, please feel free to enter them in the text box below. We have Google experts on standby to answer your questions live. So to introduce myself, my name is Madi. I am a technical trainer at Google, and I'm based in Paris. I'll be your trainer for today's event. Our agenda today has four main sections. The first section is an introduction to Google Cloud, and then we are going to discuss about virtual machines and storages, and then finally we are going to explore containers, application development, deployment, and monitoring. So let's start with our Google Cloud onboard journey. So the first section that we have today is Introduction to Google Cloud. Cloud computing has 5 fundamental attributes, according to the definition of cloud computing proposed by the United States National Institute of Standards and Technology. First, customers get computing resources on demand and self-service. Cloud computing customers use an automated interface and get the processing power, storage, and network they need, with no need for any human intervention. Second, they can access those resources over the network. Third, the provider of those resources has a big pool of them and allocate them to customers out of the pool. That allows the provider to get economics of scale by buying in bulk. Customers don't have to know or care about the exact physical location of those resources. Fourth, the resources are elastic. Customers who need more resources can get more rapidly. When they need less, they can scale back. And last, the customers pay only for what they use or reserve as they go. If they stop using resources, they stop paying. The first wave of the trends toward cloud computing was co-location. You probably have heard about co-location. It gives users the financial efficiency of renting physical spaces instead of investing in data center real estate. Virtualized data centers of today, the second wave, share similarities with the private data centers and co-location facilities of decades past. The components of virtualized data centers match the physical building blocks of hosted computing, servers, CPUs, disks, load balancers, and so on. But now they are virtual devices. Virtualization does provide a number of benefits, such as development team can move faster, you can turn capital expenses into operation expenses. With virtualization, you still maintain the infrastructure. It is still your responsibility, a user-controlled, user-configured environment. About 10 years ago or so, Google realized that its business couldn't move fast enough within the confines of the virtualized model. So Google switched to a container-based architecture, a fully automated, elastic third-wave cloud that consists of a combination of automated services and scalable data. Services automatically provision and configure the infrastructure used to run applications. Today, Google Cloud Platform makes this third-wave cloud available to Google customer. Google believes that in the future, every company, regardless of size or industry, will differentiate itself from its competitor through technology. Largely, that technology will be in the form of software. Great software is centered on data. Thus, every company is or will become a data company. Google Cloud provides a wide variety of services for managing and getting value from data at scale. Virtualized data centers brought you infrastructure as a service, IaaS, and platform as a service, PaaS, offerings. IaaS or ICE offerings provide you with raw compute storage and network, organized in ways familiar to you from physical and virtualized data centers. PaaS offerings, on the other hand, bind your code to libraries that provide access to the infrastructure your application needs, thus allow you to focus on your application logic. According to publicly available estimates, Google's network carries as much as 40% of the world's internet traffic every day. Google's network is the largest network of its kind on Earth. Google has invested billions of dollars over the years to build it, as you can see in the graph below. It's designed to give customers the highest possible throughput and lowest possible latencies for their applications across the world. The network interconnects at more than 90 internet exchanges and more than 100 points of presence worldwide. When an internet user sends traffic to a Google resource, for example, Google responds to the user's request from an edge network location that will provide the lowest latency, and Google's edge caching network sits content close to end users to minimize latency. So literally, today when you have a server hosted in Google Cloud, it can be connected with other servers around the world due to those fiber optic cables owned by Google around the globe. Now, locations at Google are divided into regions. You can think about a region like a country or a geographical independent location. Each region consists of zones, and those zones need to be at least 3 in each region. A zone is deployment area for Google Cloud resources within a region. You can think about it as a single failure domain within a region. In order to deploy fault-tolerant applications with high availability, you must deploy your applications across multiple zones in a region to help protect against unexpected failures. To protect against the loss of an entire region to natural diseases, for example, you should have a disaster recovery plan and know how to bring your application in the unlikely event that your primary region is lost. Google Cloud services and resources can be zonal, regional, or managed by Google across multiple regions. Now, you can see that USA, for example, is an exception to this because the land of USA is quite large, and we cannot just mark USA as one single region. You will find multiple regions in USA and eventually in India as well. So region is not a definition of a country. Region is just an independent geographic area. As you can see in the graph, for example, here we have in USA approximately 6 regions available right now. And globally, we have approximately 24 operational regions and 9 future regions planned and already announced, such as Paris, Madrid, Doha, and Warsaw. Let's take an example of Google's data center in Hamina, Finland, which is one of the most advanced and efficient data centers in the Google fleet. Its cooling system, which uses seawater from the Bay of Finland, reduces energy use and is the first of its kind anywhere in the world. Google is one of the world's largest corporate purchasers of wind and solar energy. Google has been 100% carbon neutral since 2007, and we have reached 100% this year of renewable energy sources for our data centers worldwide. The virtual world is built on physical infrastructure, and all those racks of humming servers use vast amount of energy. Actually, all existing data centers are estimated to use roughly 2% of the world's electricity. So Google works to make data centers run as efficient as possible. Google also is the first major cloud provider to deliver per-second billing for its infrastructure as a service compute offerings, which is Google Compute Engine. Per-second billing is offered for users of Compute Engine, Kubernetes, Google Cloud Data Proc, and App Engine. Google Cloud Compute Engine offers automatically applied sustained use discount, which is basically discounts that you get automatically for running a virtual machine instance for a certain amount of time within one billing cycle or one billing month. Specifically, when you run an instance for more than 25% of a month, Compute Engine will automatically gives you a discount for every incremental minute you use for that instance and up to 30%. Custom virtual machine types also allow you to exactly use the amount of resources that you need for your computational power. You no longer need to stick to a specific template. You can tailor your computational power exactly for your workloads. You can always check out our online pricing calculator to help you estimate your costs before starting. Google gives customers the ability to run their applications elsewhere if Google becomes no longer the best provider for their needs. This includes the usage of open APIs. So Google services are compatible with open source products. For example, you will find that Google Cloud Bigtable, a horizontally scalable managed database, uses the Apache HBase interface. So HBase is an open source. Today, if you are no longer happy with Bigtable, you can switch to another provider with no much effort. Another example is Cloud Data Proc, which offers you the open source big data environment Hadoop as a managed service. So it's based on Hadoop. If you are not satisfied with Data Proc, you can switch to any other service using Hadoop. Google also published key element of its technology using open source licenses to create ecosystem that provide customers with options other than Google. For example, you will find that TensorFlow is an open source software library for machine learning developed inside Google, is at the heart of a strong open source ecosystem, similar to Kubernetes today as well. Google provides also interoperability at multiple layers of the stack. Kubernetes and Google Kubernetes Engine gives customers the ability to mix and match microservices running across different clouds. Google Operations lets customers monitor workloads across multiple cloud providers. Google takes security very seriously. And to mention some of Google's effort to provide high level of security, we can see, for example, hardware design and provenance. Both the server boards and the network equipment in Google data centers are custom designed by Google. Google also designed custom chips, including a hardware security chip that is currently being deployed on both servers and peripherals. Premises security is also important. So Google designs and builds its own data centers, which incorporate multiple layers of physical security protection. Access to those data centers is limited to only a very small fraction of Google employees. Google additionally hosts some servers in third-party data centers where we ensure that there are Google-controlled physical security measures on top of the security layers provided by the data center operators. We have also some other measures for security, such as encryption of inter-service communication, as well as encryption in rest and encryption in transit as well. We have some advanced services, such as built-in denial of service attack protection, DOS attacks, as well as intrusion detection. We are also trying to reduce insider risk, so Google aggressively limits and actively monitors the activity of its own employees who have been granted administrative access to that infrastructure. Employees are also forced to use two-factor authentication, so to guard against phishing attacks against Google employees, all employees are always required to use two-factor authentication using an external key. When it comes to software deployment practice, so Google also employs central source control and requires two separate parties for the code review. Why should you use Google Cloud? At least for today, you are on Google Cloud OnBoard, so you'll be using Google Cloud. But generally, let's explore some of Google Cloud offerings in terms of computing power, storage, big data machine learning, and application services for your web application, mobile applications, analytic, and backend solutions. So today, we are going to divide our sections into computational power section, where we are going to discuss about compute engine, Kubernetes engine, app engine, and cloud functions. Then we also gonna touch storage services, and we will explore some of the storage solutions available on Google Cloud. Then finally, we also going to explore some big data and machine learning services on top of Google Cloud. But before we start, here are some resources for you to read more about those. Now, to continue, let's actually get started with Google Cloud. In this section, we are going to first talk about Google Cloud Resource Hierarchy, and then Identity and Access Management, IAM, and then we are going to explore what is cloud identity, and finally, how to interact with Google Cloud. So, to get started, let's first explore important security measures when you are using Google Cloud. So normally, when you are hosting your own application on your own on-prem, you are responsible for the entire stack security, from the physical security of the hardware and the premise security itself, and the encryption of whatever data moving between cables and so on. When you move your application to Google Cloud, Google handles many of the lower layers of security for you. Because of its scale, Google can deliver a higher level of security at those layers than most of its customers could afford to do themselves. The upper layer that you see in this graph is the security stack that is remaining at your own responsibility. You see here, for example, if you go for infrastructure as a service, there is approximately 40% of the stack that is your responsibility. And then when you go to managed services, then this is lowered to the minimum. So things like not forgetting your password, for example, or not leaving your laptop open in front of attackers or something like that. But then we provide you with other tools, such as IAM, to help you implement the policies that you choose for each of those layers. Now, for the resource hierarchy itself, you will maybe find it easier to understand it from the bottom up. So what you see on the screen, for example, if it's virtual machines, buckets, tables in BigQuery, and so on, they are all organized into project. Project is always the starting point for starting anything on Google Cloud. You can optionally have some folders, subfolders, to organize your organization and and divide your departments. All those folders and projects can be brought together under one organization node or multiple ones. Projects, folders, and organization nodes are all places where policies can be defined. Some Google Cloud resources let you put policies on individual resources too, like Google Storage Buckets, for example, that what we will discuss in a little bit later in the next chapter. One thing to remember, policies are always inherited downwards in the hierarchy. All Google Cloud resources belong to a Google Cloud Console project. Projects are the basis for enabling and using Google Cloud services, like managing APIs, enabling billing, adding and removing collaborators, and enabling other Google services. Each project is a separate compartment, and each resource belongs to exactly one. Projects can have different owners and users, and they are built separately, and they are managed also separately. The Cloud IAM folders feature lets you assign policies to resources at the level of granularity you choose. The resources in a folder inherits IAM policies assigned to that folder. A folder can contain projects, other folders, or a combination of both. You can use folders to group projects under an organization in a hierarchy. For example, your organization might contain multiple departments, and each has its own set of Google Cloud resources. Folders allow you to group those resources on a per department basis. For example, Folders let teams have the ability to delegate administrative rights so that they can work independently. There are some special rules associated with it. For example, you can designate an organization policy administrator so that only people with privilege can change policies. You can also assign a project creator role, which is a great way to control who can spend money on what. So how do you get an organization node? Generally, it depends on your company. Most customers are using G Suite, which is a paying service. But if you're not happy with that, then you can always sign up for Cloud Identity to be able to organize your organization node as well as your project and folder nodes. Cloud Identity and G Suite must verify the ownership of your domain before using them. So here is an example of how you might organize your resources. There are, for example, here 3 projects, each of which uses resources from several Google Cloud services. In this example, we haven't used any folders, although we may have used projects into folders, for example, if that become helpful for my needs. Nevertheless, here we see that resources inherit the policies of their parent resources. For instance, if you set a policy at the organization level, it is automatically inherited by all its children projects. And this is inheritance is transitive, which means that all resources in those projects inherit the policy too. There is one important rule to keep in mind. The policies implemented at higher level in the hierarchy can't take away access that's granted at the lower level. For example, suppose our policy is assigned to a bookshelf project, for example. Let's assume that I gave Bob the right to modify a cloud storage in bookshelf project. But the policy at the organization level says that Bob can only view cloud storage buckets, not change them. Then the more generous policy takes effect. Keep this in mind whenever you are designing your policies. So as you can see, it's always inherits from top to bottom. If you give Bob higher up there, you cannot take away privilege from the bottom of this chart. So that's about the hierarchy. Now let's explore more about the identity and access management, or IAM. IAM is the way to administrate and authorize who can take action on specific resource. So as you can see, it's the definition of who can do what on which resource. The who part can be a simple free Gmail account, for example, or any valid Google account. A valid Google account is a G Suite account, Cloud Identity account, a Gmail account, a Google Mail account, and so on. Now, this is for the humans, for the individuals. You can also use Google Groups to group people together into one single group and assign policies to them all together. You can also use something called service account for servers, intercommunication, what we will discuss in a bit later. So that's the who part. Now, the can do what part is basically the roles that you actually assign to the user. An IAM role is a collection of permissions. Most of the time, to do any meaningful operations, you need more than one permission. For example, to manage instances in a project, you need to create, delete, start, stop, and so on. So the permissions are grouped together into one single role, and you assign this role to the assigned person. And third, the resource part. So we discussed this briefly before. The resource part is where you actually assign the role to the users. The resulting policy applies to the element you choose, as well as the elements below in its hierarchy. So always it's from up to down the hierarchy, and if you give me permission in certain level, then automatically I inherit all the permissions along the way in the hierarchy. So when we talk about the roles in IAM, we will find several types of roles. Maybe the most popular one is the predefined roles, which are fine-grained permissions on particular services. The example you see on the screen is instance admin, for example. which is a role for computational power instances. You see, for example, when you grant someone the instance admin role, you give him or her the get, list, start, stop, as well as delete and set machine type, and so on. So basically, an administrator of compute engine. So you'll find a big list of many permutations of predefined rules on IAM. But if you're not happy with one certain rule, you can always go and customize it. So let's say I want to have an operator, not really an administrator, and I don't really want to grant the delete permission on the instance admin. This is where comes the custom IAM roles. So I give the instance operator role, and this person will only be able to get, list, start, and stop, but not delete. Now, when we come to talk about service accounts, so basically you can think about it as a bot or a server-to-server communication. For instance, maybe you have an application running in a virtual machine that needs to store data in Google Cloud. But you don't want to let just some person or a specific person to rely on this on him to be able to do this permission or to do this delegation of data. So you want only one specific virtual machine to do that. Here comes the service account. You can create a service account and you can programmatically allow this service account to perform this permission or this task. For service account, they have email addresses, just like any other user, but they do not use passwords. Instead, they use cryptographic keys to access resources. Now, to the third part of our agenda today, which is cloud identity. So many Google Cloud customers maybe get started by opening Google Cloud Console and start with their own Gmail account. But then to be able to collaborate with your teammates in a more performant way, maybe you can use Google Group and eventually use G Suite. G Suite customers can define policies in terms of users and groups. This way, when someone, for example, leaves your organization, you can simply remove them from the group, or when someone is onboarded, you can add them. When someone is also moving from teams, let's say from sales to marketing, you can simply move someone from one group to another. You can always also have nested groups and so on. Now, if you are not happy with G Suite or you don't want to become a G Suite customer, you can always sign up for Cloud Identity. Cloud Identity is a free alternative way that allows you to manage and create your organization nodes and then eventually manage users within this organization. But what if you already have a good number of users and you are already using probably Microsoft Active Directory or Linux LDAP system or something similar? For that, we have Google Cloud Directory Sync, which allows you to set up a scheduled one-way synchronization between your own existing Active Directory or LDAP to Google Cloud. Remember, this is one direction synchronization. We will not modify your Active Directory. We will not perform any modifications back to your system. We will just take the modification to Google Cloud. Now to the last section of today's agenda, which is interacting with Google Cloud. So far we have learned about several ways of what we can find on Google Cloud, but how actually we can get started and start use Google Cloud today. For that, we have four main ways to do this, which is basically the console, the shell and Cloud SDK, the mobile app, and the REST APIs. The console is basically the web interface that we are using all the time. So if you have signed up to Google Cloud using your Gmail account or you were invited by your colleague at work or something like that, you probably have logged into the Google Cloud Console. It's a very nice graphical user interface that lets you interact and pretty much do most of the work. But nevertheless, if you are into typing and using command line, then we have the Google Cloud SDK for you. You can download the Google Cloud SDK and use several commands such as gcloud2, gsutil, bq for BigQuery, and maybe kubectl for Kubernetes, and so on. So those tools are available in the Google Cloud SDK package. You can download them on your laptop and start use the terminal or command line right away. Now, in some conditions, if you don't want to set up this channel between your laptop and the Google Cloud, or maybe you don't have your main laptop with you, and those are other similar cases, we have got you back. We have the Cloud Shell, which is basically an online terminal inside the Google Cloud Console for you to use right away. So Cloud Shell, you will find the little icon on the top right corner of your screen that opens up a terminal inside your browser. You don't need to install anything. You don't need to download anything either. It will give you a dedicated virtual machine with 5 giga of persistent disk space, all of that for free. And it also comes pre-installed with many command lines that you will be needing to use throughout your interaction with Google Cloud, as well as some software built in for development and testing quickly, such as Java, Python, PHP, and so on, as well as other important command line tools such as Git, Maven, and so on. So all of that is available inside the browser, no need for external installation. Now, if you are a developer, then maybe you also want to have some sort of remote access to the Google Cloud through a programmatically typed application, and this is where we find the RESTful APIs. RESTful APIs practically can let anyone develop any application to interact with Google Cloud, but if you are using very specific languages such as Java, Python, and so on, then we have also some libraries available for you. You can download those libraries and start to use them right away. You don't need to write the REST APIs from scratches, and you can also explore the APIs from within your browser without starting to code at all. The API Explorer is inside Google Cloud Console. You can test the API, you can see the payload, you can see the expected results, and make sure that everything works as expected. Libraries that are available for your coding is now available in several languages, such as Java, Python, JavaScript, PHP, .NET, Go, pretty much everything, right? JavaScript, Node.js, Ruby, Objective-C, Dart, everything pretty much. So this is probably the 3 main ways to interact and administer your Google Cloud platform. We talked about the console, we talked about Shell or SDK, and we talked about the RESTful APIs. Now, there is also a mobile application, which is giving you a little bit higher level of interaction with Google Cloud. You can see specific charts tailored for you, or you can get specific notifications to your application or important notice about your billing cycle and so on. This mobile application is available on both platforms, Apple and Google Play. And here are some more resources for you. I'll leave it for you here, and let's be back shortly with the next chapter, virtual machines and storage in Google Cloud. Right, so hello and welcome again to the second chapter of today's Cloud on Board, which is about virtual machines and storage. As a reminder, if you have any question, put them in the box below this video, and I have Google experts that are available live with you to answer your questions. So to continue, let's first start with the first part, which is virtual machines in the cloud. In this section, we have an agenda of 3 subsections, which is basically the definition of what is virtual private network, or VPC, and then compute engine, and then we are going to discuss other important VPC capabilities. So let's start. What is VPC, or virtual private cloud? You can think about it as when you are connecting many computers together with a wired cable in one single room, that what you call a private networking, but you can do that now around the world inside Google Cloud. So it's still a private network, but it's around the cloud, so it's a private cloud. So this is briefly what is a VPC. It's connecting your resources around the world, and you can segment your networks use firewall rules, for example, to restrict access, create static routes, forward traffic, for example, specific destination, and so on. Many users will define their own VPC inside their first Google Cloud project, or you can just simply start with the default mode and then change it later. Now, here's an example of a VPC that has a global scope. So my example here, a VPC network called my VPC, and it happened that inside this VPC, I've created one subnetwork in the region that is called US East 1. You can dynamically increase the size of a subnetwork in a custom network by expanding the range of its IP addresses allocated to it. Doing that doesn't affect already configured VMs. So what you see here is that I have a virtual machine that is in one zone and has the IP address of 10.0.0.2. And then next to it, I have another virtual machine that is in a completely different zone and has the IP address 10.0.0.3. So even though they are in different zones, but within the same region, they are acting as one single resource, a network resource. So it's one subnet defined in one single region, and you can use it across multiple zones within the same region. However, if you want to expand that across many regions, you will be required to create multiple subnets, but then those subnets can still communicate together completely privately using the internal Google Cloud fiber optic cables. So you can use these capabilities to build solutions that are resilient, but still have some simple network layouts. So that's for the VPC. Now let's discuss the compute engine and how to start to use it today. So a compute engine is our definition for a managed virtual machine. And with managed virtual machine, you have the power and generality of a full-fledged operating system in each. You configure a virtual machine much like you build out a physical server by specifying its amount of CPUs, RAM, disks, attached disks, external disks, and so on. You can also specify the operating system, whether it's a free or non-free, and the license, and so on. Compute Engine lets you create and run your virtual machines on top of Google infrastructure. There are no upfront investments. You can run thousands of virtual CPUs on a system that is designed to be fast to offer consistent performance. You can flexibly reconfigure Compute Engine virtual machines, and a VM running on Google's cloud has unmatched worldwide network connectivity. You can create a virtual machine instance by using the Cloud console or using the G-Cloud command line that we discussed earlier. A Compute Engine instance can run Linux and Windows, or an SQL instance running on top of Windows Server. You can customize them as much as you want, and you can also import your own image if you wish. When it comes to pricing, as we discussed earlier, Compute Engine offers you per second billing, as well as some sort of discounts that are applied automatically on top of your billing cycle. So we have something called sustained use discount, which is basically when you continue to use the same resource for more than 25% of the billing month, then you can automatically get discounts applied on top of that. And this can go up to 30% per month. If you also commit and purchase a committed use of specific resource for at least 1 year, then you can qualify for committed use discount, and this can go all the way up to 57% discount. Now, if your sort of computational power that you're needing doesn't require real-time interaction and doesn't require a user to sit and use it right away, such as batch processing or machine learning or something like that that's happening on the background, maybe you can sign up for preemptible virtual machine. Preemptible virtual machines are very specific kind of virtual machines that are, first of all, not guaranteed to be available, but if available and if they stay with you all the way, then it can give you up to 80% discount on top of that. Now, preemptible virtual machine, as I said, they are very specific. They can drop at any point. If they drop before 10 minutes, then you are not charged anything. But then if they continue with you, then you get a huge discount. But then this is very specific kind of virtual machines that you cannot use for real-time interaction. It has to be used for something that does not rely on user interactivity. When it comes to choosing the exact number of CPUs and exact number of memory, you are not bound to a specific template. You are not forced to use 32 CPU, for example, and specific number of RAMs. You can actually choose the exact number of CPUs and pay for the exact number of resource that is needed for your workload. And when it comes to scalability, then you can also easily scale up and scale out your resources. So scaling up means that you increase the number of CPUs and the number of RAMs that is needed for your virtual machine. Let's say after some time you figure that your application needs more resources or more memory, you can go and modify it and then increase the resources. But sometimes increasing the resource is not efficient and it's not enough for your application. And this is where you want to add more machines to your fleet. This is what you can do through something called managed instance group. You can add a template of your machine specification and also specify what is the number of machines that you want to scale out with. So you can scale in and scale out based on also the load. Let's say, for example, from 5 to 10 or something like that, then it can go all the way down to 5 as a minimum. And then whenever there are more users or more power needed, then it can scale up to 10. Now, we have discussed the VPC, what is VPC, and also we have discussed compute engine. Now let's touch some other important VPC capabilities that you might be interested in inside your architecture. So when it comes to the topology of your VPC, much like any physical network, you need to create maybe some routing tables and firewall and so on. All of that is available as a software-based firewall and a software-based router. So no need for time to restart the router to get things propagated and to be able to read the modifications. Everything happens instantly whenever you make any modification to firewall rule and so on. You can also use tags with firewall. So if you have some, let's say, web servers and you want to give them a specific firewall rule, you do not need to assign this firewall rule to each single server separately. You can just tag them with a specific tag and create a firewall rule that is assigned to this specific tag. Now, when it comes to VPC's interactivity, we said that VPC is pair project. You create a VPC in one specific project. In some cases, you want to have multiple projects and you want to have connectivity between all of them. This is where comes the shared VPC. It allows you to share network connectivity privately still between multiple VPCs. And if you have multiple organization nodes, or if you want to interact with other organizations that are still using Google Cloud, you can use the VPC peering that allows you to still use a private channel to communicate between two different organizations. And when it comes to your global presence, you might be interested to use the Google Cloud Global Load Balancer. The example that you see in front of you is, let's say I have a user coming from Germany, and I have servers located in Tokyo, in London, and in New York. It's probably faster to direct this user to the London server to give the least latency and the best performance. So for that, you can use the global load balancer. And the interesting part about it is that it's a software-based load balancer, which means that no pre-warming is required for any modifications. If you have a hit, for example, or you're expecting an even bigger load, then all of that can be propagated instantly without any load time required. Along with the global load balancer or the load balancers in general, you might also be interested on using Cloud CDN. So Google has a global system of edge caches, and you can use this system to accelerate content delivery in your application. Your customers will experience lower network latency, and the origin of your content will experience reduced load. You can save money too. Once you have set up HTTPS load balancers, for example, then with one checkbox, you can enable also CDN. So CDN is handy to use with load balancer, but it's not the same concept. The concept here is caching some part of your application across the globe in some Google nodes, and instead of your user hitting your actual server, they will get the cached version of your JavaScript files, images, and static contents. Now, when it comes to exposing your application and you have a public IP address, one of the most important things is to actually have a DNS to map your IP address to an actual domain name. While you are free to use any third-party DNS option, you can also enjoy the Google own cloud DNS that is actually used for our own services. And cloud DNS also comes with 100% SLA. It's very important for us to make sure that the cloud DNS is always up and running all the time. So you can think about DNS as the telephone book. You generally, when you're looking for a phone number of a person, you search for his name first, and this is exactly for the domain. We search for the domain, and the domain needs to map for an IP address. Now, if this mapping doesn't happen, if the DNS is down for some reason, then maybe your server is up and running and your domain is available, but the matching is not happening. And this is why it's so critical for us to make the cloud DNS always up and running, and this is why it comes with 100% SLA. You can also programmatically manage millions of records on cloud DNS without any need for a human interaction, and the modification will go into the DNS immediately. Now, when it comes to interconnection with your actual network to Google Cloud, if it happens that you need maybe a secure channel between your office and your network or something like that, then you might be interested to use the VPN. So VPN is probably your first step to have a secure channel, and once the channel has been created, then you can exchange and interact with your servers internally using private IP addresses. But if you are interested in more secure way and you do not want to be exposed over the internet, then you can actually try to opt in for the direct peering. Direct peering lets you branch your actual network to one of the publicly available point of presence of Google services, which are available around the world. Now, when you make a direct peering, you will be actually connected to the actual Google services, but will happen only through public IP address because you are not inside our own facility. On the other side, if you want even more secure and the least latency possible between your data center and Google infrastructure, then you can opt in for dedicated interconnect. Now, dedicated interconnect is branching your cables inside Google data center and having an exact interaction completely privately between you and Google data center. But this comes with some conditions, and you must meet the Google infrastructure and connection requirements. Once you do so, you can enjoy up to 99.99% SLA when it comes to connectivity, and you will enjoy the lowest latency possible. Our point of presence and our interconnect facilities are, of course, not available around the globe. That's why if you have a physical presence issue or you don't find a point of presence, you can opt in for carrier peering or partner interconnect for doing this kind of connection. And that's it for this section. So I'll leave you with some resources to continue reading. And let's continue with the second section of our chapter, which is storage in the cloud. So in this section, we will go a little bit more deeper in some storage options. So previously we discussed the virtual machines, the actual processing power. Now let's see how to store our data. For this section, I will be discussing only 5 storage options that are popularly available on Google Cloud, such as storage, Cloud SQL, Spanner, Data Store, and Bigtable. So let's get started. I will start with cloud storage. Google Cloud Storage is a binary large object storage option. It offers developers and IT organizations durable and highly available object storage. It assesses no minimum fee. You pay only for what you use. It always also encrypts your data on the server side before it's even written to the disk at no additional charge. Data traveling between a customer's device and Google data center is also encrypted by default. You can choose the encryption option, whether it's provided by Google or you can also supply your own keys. Remember, Google Cloud Storage is not a file system. However, in some very specific cases, you can use it as a file system, such as in Dataproc, but generally it is not a file system attached to your operating system. It offers you an object storage mechanism, and those objects are immutable. Immutable means that you cannot modify them. They are only versions. You can keep multiple versions, and you can also specify how many versions you want to keep and how many versions or how old versions you want to automatically delete. You can use Google Cloud Storage for maybe some online content, backup, archive, and maybe intermediate reports and processing workloads, some log files, and so on. And to start to use Google Cloud Storage today, you need to start with something called a bucket. A bucket needs to be given a globally unique name, and this name cannot be used by any other Google Cloud customer. Now, you also specify the storage class. I'll talk about that in a bit. But you also specify the location, whether it's a regional or multi-regional bucket. When it comes to security and access permissions, you can specify the IAM policies on the bucket level, or inside the bucket, you can actually create folders and subfolders eventually, and those folders will contain your binary object or your files. And for those files, you specify something called ACL or access control list to specify the actual permission given to those specific files. As I said earlier, objects are immutable inside the bucket. Eventually, you can also enable versioning to keep multiple versions of one specific file. But after some time, you will find that you have a lot of versions and you don't really want to pay for that. That's why there is the object lifecycle management rules, where you can set a rule such as don't keep files older than a specific date, or don't keep more than 10 versions, and so on. Remember that lifecycle management rules can take up to 24 hours to take effect if it's newly created. But then once created, then it applies to new files automatically. Now let's go back to storage classes. We have four main storage classes, which is standard, nearline, cold line, archive. The main difference between them is the actual usage and the cost. So the standard is probably the one that you will use for your daily usage. Let's say your website logo or something that is accessed by your customers on daily basis. It's cheaper for access, but it's costlier for storage. But it will not make a big difference if the file size is small. Now you see the curve is going all the way for the storage price. It's going down all the way till archive, and the retrieval price increases all the way to archive. Archive is designed for disaster recovery, something that is hopefully less likely you will use, but if it happens that you need it, then the retrieval cost will be quite high. On the other side, the actual saving and storing cost is the least. Now, one important thing that you will notice here is the access time and the access API is the same across all classes. There is no such thing as waiting 2 hours for your archive data to be available or changing your APIs and programmatic interface to be able to access those different classes. All of them are accessed with the exact same APIs, and all of them are retrieved in a matter of milliseconds. Now, to upload your data inside Google Cloud, we have many options for you. We have the online transfer GSUtil tool, or drag and drop interface. So just drag and drop your file and it will be uploaded to your Google Cloud Storage. Or if you are more of typing a command line, then use the GSUtil. GSUtil stands for Google Storage Utility. You can just type it. You can also use it overnight, for example, with some other parameters for rsync to reconnect. If any drops happen to the network or something like that, then you can continue the upload process. Now, this is practical probably for some small chunks of data, but if you're coming from other cloud provider, you can set up an HTTPS endpoint and make this transfer to happen from, let's say, Amazon or other cloud provider towards Google Cloud immediately. If your amount of data that you want to upload to Google Cloud is huge, we're talking here about something like 20 terabyte or more, then you might be interested to order the rack service. You order a rack, we send you a specific rack with specific instructions on how to encrypt your data and download it inside the rack, and then you ship it back to us, and we will make it available eventually inside your product. Sometimes with some calculations, let's say 100 terabyte, and with taking into account your internet speed, you'll find that it's way much faster to make the offline transfer than trying to upload manually from your own network. There are other ways of getting your data into cloud storage. You basically can get it from logs from BigQuery, for example, or from Compute Engine or SQL queries and so on. You can also store specific backups from your data store or from your BigQuery inside Google Cloud, and you can make an interconnection between those services. So let's say I have stored some logs from App Engine, and then I'm importing them inside BigQuery for analysis. So that's possible. You can also use backup from your Cloud SQL, or you can even add some scripts, what we call the metadata script for your Compute Engine environment. And those metadata will help the startup and the shutdown operations on your computational power to be executed immediately once starting up or before shutting down. So in short, cloud storage is often the ingestion point for data being moved into the cloud. And it is frequently the long-term storage location for your data. So that's about cloud storage. Let's jump into the next storage option that we have today, which is Bigtable. Cloud Bigtable is Google's NoSQL big data database. It's the same database that powers many Google's core services, that's including search, analytics, maps, and Genial. Now, you might be interested to use Bigtable if what you're looking for is big amount of data that is semi-structured or structured, and it's larger than 1 terabyte. When you are looking for fast interactivity, so high throughput and rapidly changing data. And also when you are looking for something that is making transaction but no SQL. So no relations or semantics are required. But also Bigtable is especially needed if you are using it for time series data, so data that is has a natural semantic ordering, for example, or you can also use it when you want to run asynchronous batch or real-time processing on your data, such as the case for machine learning. So big data, as we said earlier, supports the edge-based interface, so you can use it at the edge of your pipeline, your data pipeline, and then you can connect it with your stream processing pipeline for your big data needs. Bigtable is designed to handle massive workloads at consistent low latency and high throughput. It's a great choice for both operational and analytical applications, including IoT devices, user analytics, and financial data analytics. As Cloud Bigtable is part of the Google Cloud ecosystem, it can interact with other Google Cloud services and third-party clients. From an application API perspective, data can be read from a written to cloud bigtable through a data service layer like managed virtual machines, H-based REST server, or a Java server using the H-based client. Typically, will be to serve data to applications, dashboards, and data services. Data can also be streamed in through a variety of popular stream processing frameworks, like what we just discussed, Dataflow, for example, as well as Spark streaming and Storm, and so on. If streaming is not your option, data can also be read from and written to Cloud Bigtable through batch processing like Hadoop, MapReduce, Dataflow, or Spark. Often, summarized or newly calculated data is written back to Cloud Bigtable or to a downstream database. So after this nice introduction about Bigtable and when you would consider to use it, let's take a look at other SQL options, which is Google Cloud SQL and Cloud Spanner. So let's start with Cloud SQL. What is Cloud SQL? It is an easy-to-use service that delivers fully managed relational databases. It's not actually software developed by Google. It's just a managed version of popular databases such as MySQL, Postgres, and Microsoft SQL. Every Cloud SQL instance includes a network firewall, allowing you to control network access to your database instances by granting access. Cloud SQL is easy to use if you don't really need any specific administrative level on top of the instance. So if you're matching the versions that are available inside Cloud SQL and you don't have very specific modification in the isolation, then you are most probably happy with the Cloud SQL management, and you don't have to take care about the security, the backup, the failover, and all those other redundant workload to do because it's already managed by Google. So you can sign up for backups, for example, horizontal scalability, vertical scalability as well, of course, and as well as Google security on top of all of that. Another benefit of using Cloud SQL is that they are accessible by other Google Cloud services and even external services. You can use Google Cloud with an app engine, for example, or you can make a connector with your application inside Google Compute Engine. Google Cloud SQL can also work as a standalone database, and you can connect it to an external service or a third-party service, and you have your data hosted inside Google Cloud. Now, if what you're looking for is more of a horizontal scalability and availability across multiple regions, then you might be interested in Cloud Spanner. It supports strong consistency, including strong, consistent secondary indexes, SQL, and managed instances with high availability. It has also a built-in data application. Cloud Spanner was originally built and developed totally for internal Google products, and now it's available for you to use. It has been tested by Google's own mission-critical application and services, and it is powering some of Google's biggest businesses out there. Cloud Spanner will be especially for you if what you're looking for an SQL RDBMS with joins and secondary indexes. If you are looking for built-in high availability and horizontal scalability, if you are looking for strong consistency, and especially if your database size exceeding 2 terabytes. And on top of that, it also suitable for you if what you are looking for is many IOPS, some tens of thousands of read and writes per second. So that was our offerings for SQL databases. Briefly, we said that Cloud SQL is a managed version of a third-party databases such as MySQL, Postgres, and Microsoft SQL. On the other side, if you want a Google-owned designed database engine, then you might be interested in Cloud Spanner. Now, there is also another database designed by Google, but it's a NoSQL database called Datastore/Firestore. The new name will eventually be called Firestore. Cloud Datastore is highly scalable NoSQL database for your applications. Like Bigtable, there is no need for you to provision database instances. It's perfect to use with mobile applications and web applications, and it is using a distributed architecture to automatically manage scaling. It runs on top of Google data centers, which uses redundancy to minimize impacts from points of failure. The total size of cloud data store databases can grow to terabytes and even more. So data store is probably your best solution if what you're looking for is a database for your mobile and web application, but you can also afford the NoSQL database. And as a summary, let's take a comparison between all those databases that we just discussed. So as you can see, in the middle part, we have cloud storage, which is perfect for non-tabular data, your binary files, for example. You can use it whenever you want to store, let's say, videos, images, and so on. However, if what you're looking for is storing some sort of a database and you want to query it with SQL, then we have Cloud SQL and Spanner. As we just discussed earlier, Cloud SQL is just a managed classical database like MS SQL, MySQL, or Postgres. However, Cloud Spanner provides you with even bigger capacity and the possibility of horizontal scaling as well as higher consistency. Now, if your solution is a NoSQL database, then we have Cloud Data Store / Firestore, which is a perfect solution for your mobile and web applications. However, if you are looking for heavy read writes and you want to connect, let's say, with IoT device or data analyticals, your requirement is data analyticals, then Bigtable is perfect for you. You will find on the last column a mention about BigQuery. We are not gonna discuss it much in this module. It's more of big data and machine learning, but the mention here is just for visibility to be able to see the differences. However, I need to mention that BigQuery is not a database. You cannot use it as a backend for your web application, for example. It is meant as a warehouse data analysis. You can query your data and you will get fast results, but the latency is not as fast. Now, you can also see some use cases and best use, so you can make your decision and comparison. So briefly speaking, we can say that cloud data store is best for semi-structured application data, and Bigtable is best for analytical data with heavy read-writes events, like maybe ad tech, financial, or IoT devices. Now, cloud storage, as I said, is best for structured or unstructured binary or object data, like images, large media files, or maybe backups. Cloud SQL is a best tool to use when you have already an existing database, like MySQL, for example, and you want to migrate to Google Cloud. You can also use it with most of the popular web frameworks to store your credentials, user base, something that requires some relational work. Cloud Spanner, on the other side, is best for large-scale database application that need to span across multiple regions and need to have horizontal scaling as well as even higher capacity, bigger than those 30 terabytes. So as I mentioned at the beginning of the module, depending on your application, you might use one or several of those services to get the job done. And that's it for this chapter. I'll leave you with those additional links for resources about the storage options that we just discussed. And see you soon in the next chapter about containers, app development, and monitoring in Google Cloud.